The first topic we're going to cover is tool geometry. When we're talking about tool geometry, there's three angles we need to familiarize ourselves with. The first of which is going to be the hook angle. The hook angle is the angle that's milled into the cutter head. The cutter heads that we recommend are dual hook angle heads, where two of the slots are 15 degree and two are 22. Depending on the type of wood that you're going to run through the machine is going to determine the hook angle that you use. The harder the wood, the lower the angle. The softer the wood, the higher the angle. So if you were going to run oak, for instance, you would put the two knives in the 15 degree slots. If you were going to run pine or poplar, you'd put the knives in the 22 degree slots. So the grooves that are milled into the cutter head, that's referred to as the hook angle. The second angle we're going to talk about is the sharpness angle. The sharpness angle is the bevel that's put on the knife. That is your sharpness angle. The third angle is the clearance angle. The clearance angle is the angle behind the knife when it makes contact with the workpiece. This angle is important because it actually cools the high-speed steel as it's turning and prevents the knife from dulling and overheating. That's called the clearance angle. The total of these three angles needs to add up to 90 degrees. For example, if we know that our hook angle is 15 degrees and the clearance angle is determined on our grinder, and for most operations it's 25 degrees. So if we take a 25 degree clearance angle, a 15 degree hook angle, your total is 40 degrees. So then you would know that your sharpness angle would be 50 degrees because the total of these three need to add up to 90 degrees. There's nothing you can do to the hook angle. It's fixed into the cutter head. The clearance angle is determined on the grinder. So by knowing your clearance and your hook, you can figure out what your sharpness angle is. Once you change your clearance, then you've changed your sharpness. If you want to change your sharpness, then you also change your clearance. So you have to know that if you change one of these, it affects the other and vice versa, yet your hook angle is fixed. The next topic we're going to cover is the sizing of the template and of the bar stock. There are certain things that needed to be added to the profile dimensions in order to get the proper template size and the proper bar stock size. If we take a sample pattern of a casing that's 3 inches wide and 3/4 of an inch thick, when we're sizing our template, we want to add 1.5 inches to the width of the profile. We want to add 2 inches to the deepest part of the profile to determine the size of our template. To determine the size of our bar stock, we want to add 1/2 inch to the width and add 1.25 inches to the depth. The deepest part of the template is going to actually finish up to be the thickest part of the trim. So if we use this profile as an example, add these numbers to it, our template's going to be 4.5 inches wide by 2 3/4 inches. You're adding 1.5 inches to the width and 2 inches to the thickness. Using this same example for our bar stock, the bar stock would be 3.5 inches by 2 inches. The next thing we're going to cover is, we know what the size of our template is in our bar stock. Now we have to determine the best way to lay them out. The next topic we're going to cover is the layout of the template and the bar stock. We've already gone over how to size the template and the bar stock. Now we're going to go over the layout. If we know that the width of the profile was 3 inches and we added 1.5 inches to the width, when we're laying out our template, we want to start our profile 3/4 of an inch in from the left side of the template. So by doing that, if we oversize it 1.5 inches, when we get done with the right side of the profile, we'll have a 3/4 inch shoulder as well. You can see here our finished thickness was 3/4 of an inch, so we have 2 inches above and beyond the 3/4 inch mark. That's how you're going to lay out your template. Laying out your bar stock, you're going to end up having a 1/4 inch shoulder on the left side and a 1/4 inch shoulder on the right side. And this is important because as we go further along in the video, we're going to cover axial constant. So what we want to do is, if this is our bar stock, we grind away the excess material to give us our profile. The distance from here to here is going to be 1/4 of an inch. And we want to be consistent. For every set of knives that we grind from here on out, you want this distance to be the same. So when you go to set up this profile, it's going to be one less step that you're going to have to go through when setting up the machine. If the distance from here to here is the same, then when you put that cutter head on the top spindle, for example, it's going to be lined up properly with the fence of the machine. So you need to be consistent when you determine what this distance is going to be. The next topic we're going to discuss are a few of the different types of cutter heads available on the market today. The first one we're going to take a look at is the most popular. It's a straight bore, double hook angle, 4-wing cutter head. Addresses both the hardwoods and the softwoods. The second cutter head we're going to discuss is a Hydrolock cutter head, which requires a high-pressure grease gun in order to operate. This particular head is a 6-wing head, has a single hook angle. They're available anywhere from 4 to 8 wings. The third cutter head we're going to discuss is an insert cutter head. This particular one is used for a stile and rail application in order to ensure a good tight fit when you're doing your cope and stick. The knives are disposable. When they get dull or get a nick in them, you throw them away, put a new set in. Fourth cutter head we're going to discuss is a milled to pattern cutter head dedicated to one particular profile. This is generally made out of carbide. You don't get as good a finish with this particular head as opposed to high-speed steel, but it enables you to run longer without having to be resharpened. This particular head is dedicated to one profile and one profile only. The last head we're going to talk about is, again, an insert cutter head made with straight knives. These knives are locked into place by centrifugal force. They're ideal for S4S applications. If you were to get a nick in the cutter in the knife, or you were going to get a dull knife, if you wanted to change the knife, you depress the gib, pull the knife out, flip it over, and you have a new clean edge. This can be done with the cutter head on the machine. You don't have to lose the downtime to resharpen and put new knives in there.
The items you see here must be acquired if you plan to make your own tooling and your own templates. These include a file assortment, needle files, a balance scale that measures in grams, T-handled metric Allen wrenches, an assortment of fine sandpaper, a granite setup block, a metal cutting chop saw, a bench grinder, an assortment of template stock in plastic or metal, a bench vise, a scribe, a good quality machinist square, a set of radius gauges, and machinist calipers. This is the measuring stand that comes standard with your molder. It is essential for the quick setup feature. The first thing we need to do is zero out the caliper. We move the extension rod up against the stop at the top of the spindle, and we push the 0 button. All your numbers should read 0. Once that's accomplished, we then reverse the rod and then align it with the deepest profile on your cutter head. At this point, we can push it against the deepest part of the profile, turn the cutter head slightly to get it at top dead center, and we take our reading. This reading will represent the radius because we're working from the halfway line mark of the spindle to the deepest part of the profile. The dimension we're looking for is diameter. So the number you see here now needs to be doubled. And once you double that number, that'll be the diameter and the minimum cutting circle. And that's the information we plug into each digital readout of the head that we change. Here we are at the control panel. Let's talk about all the controls in this general area here. The first thing we're going to do is turn the power on. The master switch is located behind the control panel, and when we turn the power on light comes on to tell us that the machine is now live. As we work with the top row of buttons, the first set of buttons are the feed on buttons. These are used to continuously run the feed system after the machine is totally set up and the boards want to feed through the machine continuously. These buttons only work with the hood in the down position. The next set of buttons are our forward and reverse jog buttons. These are used to run test pieces. The jog system only works while the button is in the down position, like you see here. These can be used with the hood in the up position. If we want to reverse our piece and bring it back out, you can see how that operates as well. Let's continue down the control panel and talk about the next switch in line. That's going to be our raising and lowering of the beam switch. When we refer to the beam, what we're talking about is the entire top section of the Superset 23. That would include feed wheels, cutter heads, hold-down shoes, and all of the other related components. If we want to raise the beam, we turn it in this position, and you can see the beam and the feed works going in the up position. If we want to bring it down, we do just the opposite, and now you can see here how it all goes down. The next switch in line is a unique feature to SCMI. Here we can separate the feed wheels from the cutter head. If we need more feed wheel pressure, but we want to maintain constant thickness, we flip this switch over, and now only the feed wheels will go up, like you see here, and go down, like you see here. Once we return this switch to the original position, the feed wheels will return to the automatic setup position automatically. The next switch we have here is another unique feature to SCMI. This machine is retrofittable for a universal head. The switch that we see here for rotation and the one directly below it are not operational now because this machine does not have a universal head. But if you order this option on your machine, you can order and install a universal head anytime in the future. And finally, on the top row, we have the emergency stop button. To activate it, we push it down, and this will kill everything on the machine, spindles and feed system. To release it, we twist it, and it snaps back up, and we can restart the machine. The next row of switches are for the spindle motors. Each one has an individual start button, and they're all star delta starters. When we depress the button, the motor will start turning, and when it gets up to full speed, the green light will illuminate, telling us that that particular motor is up to full speed. The first one is going to be for our first bottom head. Then we move to the right and left vertical, which are driven by one motor. Here we have the top horizontal head, and then finally we have the last bottom head on this machine. Now keep in mind, as I mentioned before, the other two switches here are for an add-on universal head that we might put on anytime in the future. And then we have our power on light, which tells us that the machine is live. Next to the control panel, we have our pressure control group. Let's take a look at these one at a time and see what they do. Now, starting at the top, we have the pressure control gauge and control regulator for the chip breaker just before the top horizontal head. You'll notice the gauges have two scales, one in bars, one in PSI. To change the pressure, we pull the knob out, and we can rotate to decrease the pressure, or we can turn the other way to increase the pressure. All of the knobs work in the same fashion. The next one down is for the outfeed rollers. These are the two rubber rollers at the end of the machine. Going down from there are the infeed rollers. These will be the steel rollers before the top horizontal head. And the very first infeed roller, just below that, will now have its own separate pressure so we can regulate and possibly not flatten the board too much for straightening operations.